Now let us study about an interesting phenomenon called as polarization by reflection. Okay, so we can produce a polarized light with the help of reflection. Okay, let's study it now how it is possible. So let's take a surface like this. Say a medium here. We have air and water. Okay, for example, we'll take two medium here. The first medium is say air. The second medium down is water. Okay, what we're going to do is we're going to take this as a normal here. Okay, first we'll draw a normal here. This line is a normal. Okay, now what happens is we send a light ray from here, an instant light ray we're sending here. Okay, we send an instant light ray like this way. So this is a incident light. Instant light beam. Okay, I've drawn just one ray, but we can draw a group of rays that will be a beam. Okay, now the instant light ray, if you see, it is not just having any particular plane. Okay, it vibrates in all the plane of vibrations. Okay, so if you see this point here, the light ray will vibrate up and down, okay, sideways, in all the directions it will vibrate. Okay, it's we say unpolarized light we say. Okay, so it has both perpendicular components and parallel components. Let's see that now what does it mean. Okay, it's at an angle here. The angle of incidence we write as IP. Okay, this will say why we write IP. We'll say later. Now it has components like this way. I will put dots here. Okay, dots means that the light ray vibrates like this way out of the plane of the board. It goes outside like this way. Okay, then I'll draw another light rays like this way, or the arrow marks like this. This shows the light ray vibrates in this plane. Okay, like this way. So there are two kinds here. One is it will vibrate like this way. Other one is it will vibrate out of the board. Okay. Now at this point, okay, there's a reflection happening. Okay, so light ray will get reflected. So we can know angle of incidence is equal to angle of reflection. Okay. So this angle also will be IP. So this is a reflected ray. Reflected ray. Okay. So the reflected ray comes here. Now if you see that in the reflected ray, okay, the dots we saw now, okay, that will be here. Okay, actually these are not just dots. This means that light ray vibrates like this way out of the board. Okay, then let's see what happens to this component here. The light ray which vibrates like this way. Okay, that light ray if you see, it will be refracted here. Okay, it will bend here. It will go into the water. Okay, light ray will bend inside the water. We know. So if you see that at a special angle of IP, the reflected ray and this is the refracted ray. Okay, this ray is a refracted ray. They both at 90 degrees to each other. Okay, so if you see that the dot component, that means this component going out of the board, that will go in the upward direction, and the parallel component, okay, or this vertical component here will be like this way. It will go down here. Okay, you see it won't be exactly fully pure. Some light rays, okay, may have both the components here. Okay, the component going out of the board and the component going along the plane of the board. Okay, you have these two things. So, and this angle you mark it as, say, angle is RP, the angle of refraction. So let's name these angles here. We see that IP. Okay, so that's a special angle IP only will get this thing, two rays. The reflected ray and the refracted ray will be parallel to each other. So IP here stands for, we can say, polarizing angle. Okay, polarizing angle. Polarizing angle. So with the help of reflection you can make polarized light. Okay, then angle RP means the angle of refraction. Okay, angle of refraction. Okay, these things you must know. Okay, so just by sending a light ray on top of any surface here, we can make a polarized light. Okay, so this is a very simple method. It's called as polarization by reflection. Thank you for watching.